Optical Associates OAI Hybralign Series 500 mask aligner. This system is set up for exposing 4-inch wafers using a 5-inch mask. I have a substrate or a wafer which is a 4-inch diameter, and you load the substrate and then load the mask, and this is the mask clamp which is held on the vacuum with the pneumatic switch here, mask clamp vacuum. In between the exposures, use the mask frame lock to turn it off, and then the mask frame is unlocked, and turn off the substrate vacuum, and you can replace the substrate. So turn it on, and under the mask there is a vacuum cup here, which is the mask frame lock vacuum cup. Before proceeding with the alignment, the mask should be adjusted for getting the image on the split field microscope. For example, if you want to see the alignment patterns on the mask evenly, then use the mask rotation knobs on either end here, one on the front on the left, and one on the right hand side rear, and make sure that we get the image evenly. And to focus the image, use the micrometer on the microscope frame. There's a zoom facility. We can also adjust zoom and get a larger image for better clarity. There are two vacuum switches on the manipulator arm here. You pressing that allows to move the microscopes. So it's a split field microscope with two microscope arms which can be moved on this horizontal bar, and there are lock knobs on the back side of the arm here, the mounting plate. You have to loosen those in order to move them sidewise like that. And there's a zoom adjustment here, and the focus knob here, and the microscope illuminator brightness can be adjusted. The knob here on the main console. So once the alignment of the patterns on the mask are done, press the foot switch and rotate the chuck clip knob on the right hand side of the alignment module rotate the knob counterclockwise to lift up the sample to touch the substrate. Make sure it's even, and once we get the substrate in contact with the mask, rotate the knob clockwise to lower the chuck by a known amount by looking at the reading on the scale here. Once there is a gap between the substrate and the mask, now we are ready for proceeding with the alignment of the sample. So I can move the substrate. The image is shown moving on the monitors. This is the knob on the left hand side is for x-axis movement. The knob on the front is for the y-axis. And there is a third knob here which is for rotation, which will rotate the substrate along the vertical axis. Now, the alignment patterns on the mask and the substrate, once they are properly aligned, rotate the z-axis knob up again, and then proceed with exposure by pressing the expose button. So once the expose button is pressed, the lamp housing will move to the chuck area, and the shutter will open for the duration set on the timer here. The timer can be set in 100 seconds maximum or 1000 seconds. Once the exposure is over, press load unload button and press reset button so that the shutter will not open. At any point of time to test the lamp touch button can be used, and to test the timer, the expose button can be used. On the right hand side of the console, there are three pneumatic switches. The first one is for mask frame lock, and the second one is chuck release. The chuck release will release the chuck and lower the chuck, but if you turn it on, the chuck will be lifted by the amount that is set using the z-axis knob here. So the chuck will be moving up and down. If the chuck is all the way down, then it will be lifted up. And this is mask clamp switch, which clamps the mask to the mask screw here. And there's also a pneumatic switch for contact vacuum. The contact vacuum is generated between the substrate and the bottom side of the mask, and this is a standard mask holder where the vacuum will be generated between the mask frame and the substrate. And there is a sealed gasket on the bottom side of the mask frame. Now this contact vacuum is adjustable using this knob, and whenever the contact vacuum is turned off after the exposure, make sure that there is nitrogen flowing. This nitrogen purge is used to release the vacuum between the substrate and the mass. Now, I have released the mass frame lock. Once the exposure is completed, this will allow to remove the substrate and replace it and get it ready for the next exposure. This is a vacuum seal gasket. Always care should be taken in order to not to have any wrinkles on the gasket, which is a 0.020 inches thickness silicone gasket. Currently, the system is running in constant power mode using this radiation technology arc lamp power supply. The lamp wattage is 500 watts, and in constant power mode, this knob is used to reduce or increase the wattage of the lamp. So when the system is not used for exposure, it is always good to leave the power supply running at about 75 to 80% of the maximum wattage power, and then increase it just before the exposure. The system is also capable of regulating the intensity of the UV radiations, for which the mode selector switch should be moved to constant intensity mode, and to display the intensity, the intensity power switch should be in intensity mode. And now we are ready to run the system in constant intensity mode. There are two detectors inside the lamp housing. One of them is rated for 365 watt nanometers, and the second one is for 405 nanometers. So I have a detector here to demonstrate the intensity of the UV radiations here. At 365 watts, the intensity level is about 12.5 watts. So if we select channel A and we adjust the calibration knob, in order to tally the intensity reading here, to match with the reading on the external detector. So 12 milliwatt per centimeter square will be that. So it's an analog readout. Now we can set the power for this channel either below 12 milliwatt per centimeter square or above that value. And you can increase and decrease it. Switching it to the channel B, which is for the 405 nanometers, and the reading is about 31 milliwatt per centimeter square. Now it has been already calibrated, And now we can set it higher or lower. So what it does is, by adjusting the set point, we are actually decreasing or increasing the power going to the lamp. Thereby, you are able to achieve a constant intensity of power in milliwatt per centimeter square UV energy levels. With the lamp removed from the lamp housing, and there is a dedicated exhaust fan to cool the lamp housing, and the power to the cooling fan, exhaust cooling fan, is connected to the lamp power supply. The system requires compressed air about 60 psi and nitrogen about 20 psi, and a vacuum pump which is to be connected to the vacuum port here up to 30 inches, 25 to 30 inches of mercury. The system also has pneumatic bellows which are located at 3 locations, one on the front and 2 on the rear side, left hand corner and right hand corner. These bellows are to be filled up to 32 psi of compressed air just before starting to use the system. So what it will do, the bellows will enable the lamp housing to be isolated and make it vibration free. After locating the system at its final location, the system should be level such that the alignment module is evenly level with respect to the mask. And both the cameras can be adjusted to focus the images to be focused and visible on the monitors. If it is required, the set screws on the camera microscope modules can be loosened and lifted up or down in order to get both the cameras focused simultaneously. The mask aligner will be shipped in this condition without the substrate holder on the chuck. And there is a yellow line here which will be labeled N2 purge. This line is attached to the nitrogen flow regulator here. And this N2 purge is to be connected to this brass bob fitting on the substrate holder. The substrate holder, the bottom side, it has a ball mechanism which will pivot it in such a way the substrate will become parallel to the mask when we press the foot switch and raise the chuck up. And there are other 2 vacuum lines which are these 2. One is for contact vacuum labeled CONT, and the other one is for substrate vacuum. And the contact vacuum line is to be connected to the connector on the right hand side, and the substrate vacuum to the one on the left hand side. So make sure first the nitrogen line is connected properly. The nitrogen purge line, which is the yellow line. And once you connect the nitrogen line, then set the substrate holder in the cup, and then connect the contact vacuum line and the substrate vacuum lines. Right now the vacuum pump is off, and that's why the chuck is freely moving. When we turn on the vacuum pump, once we turn it on, the chuck will be stable in one direction. So you press the foot switch and then you can move it easily. So once the substrate holder is loaded, then lower the mask frame and turn on the mask frame lock. Now it's time to load the insert, which is a reducer from 7-inch to 5-inch masks. So first place the insert here so that the sealing, the vacuum seal O-ring is visible on the top, the 5-inch, for the 5-inch mask. Load it like that against the pins. And now load the mask with the pattern facing the substrate holder. The pattern should be on the bottom side. So load the mask and push it against the 3 pins. And if necessary, press the align button, and there is a small allowance to rotate the mask so that the patterns on both sides, left hand side and the right hand side, both alignment patterns are visible on the monitors. And this is the mask frame clamp, so this clamps the mask down using the suction cups. So press the mask clamp and turn on the vacuum. Now it is held on the vacuum, so the mask is stable now. Now once the mask is stable, turn on the mask frame lock vacuum, lift it up, and then you load the sample to proceed further.